Video. So this is video number 2 for module 1. Once again, some pretty basic stuff, but let's get right into it. So what are we talking about today? So we're going on about PAG investigations and exam questions. So we're first going to talk about the mean. So you should know from primary school, basically, the mean is the average. So mean brackets average is the sum of repeated measurements. If we're talking about repeats in an experiment, over number of repeats. We all know what the mean is. It increases the accuracy because it reduces the chance of random error, blah blah blah. Talked about that in my last video. So, as we should know by now, we ignore anomalous results. So, I say ignore. Ideally, what we should do, if we're doing a PAG investigation and we notice that one result does not fit the trend, the general trend at all, I mean, obviously, if there's no correlation, then it's fine. But if we see a result does not fit a trend, then we should ideally redo that individual reading. But obviously, in an exam, that can't be done, so we just need to ignore it when taking into our calculations. So I'll show you what I mean. I do apologise, this isn't a very good example because I didn't have a ruler on me, but basically if we're asked in the exam to draw a line of best fit, you would ignore this anomalous result because, as you can see, it does not fit the general trend. So you would just ignore that or exclude it and just carry on drawing to the general trend, which if you're asked to do any kind of analysis or anything or conclusions, you could obviously mention that there. But so yeah, down below I also drew, as I'm sure you guys know, what positive correlation is. So as this variable on the x-axis increases, there is an equal increase in the variable on the y-axis. Vice versa for the negative correlation, and obviously zero correlation is just no relationship, or yeah, just no relationship, statistical relationship between the two variables. So yeah, that's what I was talking about. I do apologise for the bad drawing there. So obviously going on about correlations. So often exam questions will ask you to state the relationship between two variables. So, for example, simple harmonic motion, which you'll come across in year 13, it'll say there'll be like a graph and it'll be directly proportional, and it will say how you know something is directly proportional, or sorry, how you know that simple harmonic motion has taken place. And you'd be able to tell because the graph would have be directly proportional, but you wouldn't say that. This is just an example, but if two things are directly proportional, you wouldn't say in an exam answer they're directly proportional. You would say that the line passes through the origin. So I'll just write that down. Line passes through origin, therefore directly proportional. Obviously you wouldn't say it that briefly, but yeah, you guys get the general gist of it. And then perhaps for, if it was 2 marks, you would plug in a few values of the gradient and just to show that they are directly proportional, or use some kind of constant equation where you make the constant of proportionality the subject and blah blah blah, you know. But we'll be getting into that in further videos, but I'm getting too ahead of myself. So yeah, that's just so you guys know about relationships and correlations, etc. That you can get. So at GCSE, I'm sure you'll know that gradient is just changing y over changing x. So we know that, and we still use that. Whoa. Oh, focus. There we go. Nope. It's thinking about it. There we go. So, I'm sure you know it's changing y and changing x. You've been doing that for a long time. But, basically, if you've got a graph, let's say something like this. Once again, I do apologise for not having a ruler. Very unprofessional of me. So, say if we have something like that. And we wanted to find out the gradient what the rate of change of these two variables was here, what we would do is draw a tangent. God, I do apologise that I'm not using a ruler. Never ever do this yourselves. So yeah, you'd find the gradient of this tangent here. So that would be used in things such as, I don't know, instantaneous acceleration. Say if this was velocity against time of some car or something, I don't know, but yeah. And also another thing is that often in your PAG investigations you'll get relationships that don't quite look like they have any kind of correlation. Let me show you an example. There we go. So yeah, these two graphs here are taken from the ideal gases. You'll get to that in year 13. But so this graph here looks like there's some kind of curvy negative correlation. However, if we often get results like this in our PAG investigations throughout A-level physics. So it's worth noting that if you get a graph like this, if you draw pressure over 1 over area, we can see that they're directly proportional because they go through the origin. So that's one thing worth noting, and that could be easier for your calculations, etc. So there you go. I think that just about wraps up this video on analysing results in OCR A-level physics, OCR A spec. So if you enjoyed it, if it's helped you, please like, comment and subscribe. Peace.